Today I want to discuss the problem regarding the loss of safety, and I'll discuss the problem regarding the law of pulse safety. Let's imagine that we have the following situation. We have some board. Here is the board, and there is a human. As this board. Let's draw him. He has blonde hairs, and this is not so important for this case. What kind of hair does he have? And he can move through this board. And we have some lake at the surface of our water. And I will identify the distance on which this board can move from this position when this target human moves to the end of this board. Okay, and let's write the law of safety of our pulses. Our human has the mass m1 and he has the velocity v1 plus m2 v2 is the mass and the velocity of our board, and it's all equals to 0 because we don't have any external forces, and we have the inertial system of coordinates. And I want to identify the distance on which this board can move when he will cross this distance. And let's identify this distance. And these two vectors v1 and v2 are the vectors regarding some bank of this river. Why is it so important? I'll explain. The bank of the river doesn't move. The boat and the human moves. Their velocities are enough different, and this human during his movement on this boat, on every step, moves. He makes some steps. For example, he comes here. His blend has here, for example, and he moves with some velocity v1 regarding the bank of the river. And let's imagine that we have this board, of course. This board, of course, gains some velocity v2 regarding, of course, this bank of the river too. And the energy of pulsation is written here in such way form. The same moment, the human can move regarding the boat, and his velocity is connected with the velocity of this boat by the following law: v2 plus v apostrophe, where v apostrophe is the speed regarding this boat, and v2 is the speed of the boat regarding this bank of the river. It lets us to write this. It lets us to write this equation in the following form: m v2 plus v apostrophe plus it's m1 plus m2 v2 equals 0. Then we can write that we will collect all terms connected with this velocity. It's one side of the equation and the left side of the equation, and all terms with this velocity is the right side of the equation. And let's rewrite it. V apostrophe m1 plus m1 v2 plus m2 v2, and this all equals 0. V apostrophe equals minus m1 v2 plus m2 v2, and this all should be divided in 1. What does it mean? It means that the velocity of the human regarding this boat is directed in opposite sides. When we have rewritten this equation using only projections on this OX x, it's only projections because we don't have any vectors here. We can tell that if we will direct the x or x in this form, the velocity of this human can be directed, for example, in this direction. Then the velocity of the boat will be directed in the opposite side. And that's why these directions are connected with the following relation and with this sign of minus. And if we have the constant velocity, and if this human moves with very slowly, it means that we don't have any external forces, of course. Then it can be written that V apostrophe multiplication on the time of his movement equals minus V2 and some relation connected with the mass of the human and this boat. And we'll take it all as our consideration. The main equation of distance on which this boat can move can be identified through the formulation. It's our distance of our movement of our human minus r the distance of movement of our boat m1 plus m2. This sign value means that this vector directed in opposite directions, but if we want to define what distance is much more, or calculate the absolute distance, we can take the modulus of these relations, and the final relation is represented as m1 plus m2 divided m1. And so, this is a connection of our vectors and the distance on which the boat can move. The boat moves at this position R when the human changes his position from this point, his lucky and his hands, to this one. For example, where r apostrophe can be the length of this boat. And I'll mention again that his motion should be slow and the velocity should be constant. Because in another case, when he'll jump, this law can be, of course, realized, because this vector and can be gained in the following form, of course, after integration of this unit. And if we don't have the constant velocity, we can tell that this the integral of the streak with some law on the time. And that's why this human can move slowly to this point, or he can jump to this point immediately. And all of this type of the movement will fall to the same distance of boat displacement as within this lake. Thank you for your attention.